Okay, so we're going to talk about connectivity, communications, and infrastructures. We talked before about the 5G, and now it's time to talk again for the 5G. So thanks for joining us. So we have Marcos Pillado, please, product manager at Applus Idiada. So you can sit here if you want.
No, actually, I'm the moderator of the discussion panel.
El moderator. Bueno, ¿te quieres sentar
No,
aquí?
donde quieras. Sí,
Vale, vale.
donde tú quieras.
En principio,
Porque es que han dejado solo 3 sitios. Vale, por eso te lo digo. Es que por eso te lo digo.
Abel, Carbonell, Head of Electronics at Idiada, José Manuel Caramés, Director of IoT en Telefónica, y Javier Barahonda, Head of Telefónica Management at Ericsson. Thanks so much for being here.
So, good afternoon, ladies, gentlemen. I'm the moderator of this discussion panel about driving on 5G. So, as we have seen here, so the market is changing. We see automotive industry is getting closer to telecommunications. So we are seeing that this is a clear example. So the motor show in Barcelona is changing as called automobile. Here we have 3 speakers that they are coming from different domains. We see colleagues that are coming from automotive industry, colleagues coming from the telecom industry. Here we are going to present what are project that is going to bring an ecosystem and provide solutions for connecting automated vehicles that, as we see, 5G networks are providing new opportunities, are changing, transforming the society, and this is the case for the automotive domain. So the project that we are going to present here is a new ecosystem. We will see how 5G is going to enable new opportunities. So I will give the time for the speakers. Our first speaker is Mr. José Manuel Caramés. He is director of the IoT go-to-market in the Internet of Things business area at Telefónica Group. He joined Telefónica in 2013. Before, in 2008, he co-founded a startup dedicated to electronic vehicles and telematics, where he held the position of business development director. Before that period, Mr. Caramés was senior associate at Oliver Wyman Group, developing a strategy consulting for utilities and telco companies. He holds a bachelor's business degree from Ramon Llull University and an MBA from IE Business School. So the title of his presentation is Leading the Technological Transformation of 5G. So Mr. José Manuel Caramés, the floor is yours.
Good afternoon. Thanks, Marcos, for the introduction. So, 5G. First of all, I would like to share with you the network evolution that is suffering this industry and the new paradigm that we are starting to live. All of us, as consumers, at the end, we have experienced the evolution of the different network generations through our smartphones, through our devices, and 2G, 3G, 4G. We can see that around 10 years, we can see a new generation having a higher speed, more capacity, and at the end, more capabilities, more functionalities, evolving and evolving regarding the demand of the customers. But this has other side of the story, which is the battery consumption that requires these different generations. So today, nowadays, we are living, as you know, in the 4G generation, which is, as you can see in the chart, the LTE Advanced, which is already available in your smartphones. But something we saw from the industry is that beyond this high level of demand coming from consumers, we had other type of use cases and other type of demands more related to the famous Internet of Things. So the expectation and the predictions is to have millions and hundreds of millions and thousands of millions of devices connected using low data traffic and demanding or having low consumption, battery consumption, but more important, needing the capacity to connect at the same time millions of devices. That's the reason to have in this chart a crossroad with two different paths. One is the scenario regarding the complexity, so the demand coming especially from consumers asking or requesting for more capacity and for more features. But on the other hand, we have a scenario needing lower data consumption and lower battery consumption. So in this simplicity scenario, simple scenario, we are seeing different standards. Some of them already available, like LTE-M that was presented in the last Mobile World Congress, or LTE-V with nowadays with pilots, or some others coming like narrowband IoT. What's the new paradigm? Here the new paradigm is that at the end these two different paths are ending in one single new generation, which is the 5G, and the paradigm is that will be the first standard being able to have the best of both worlds, no? So the demanding one or the complex one and the simple one, and that's very relevant to understand better what's coming. So having more or less a high-level view of the network evolution, I think it makes sense to understand a bit about the features and the use cases specifically for the automotive industry that is having impact from the 5G generation. As I was mentioning, the complex scenario, the features is higher bandwidth, faster connectivity, and higher mobility. And this is not enabling infotainment services, because at the end with the 4G we have all these services available, real-time navigation or Wi-Fi, hotspot, but it's true that will improve these services having better quality and at the end a better service. From the other side of the story, as I was mentioning, the simpler one, the step forward is really huge. The new features is the low latency, as you know, security, absolutely critical for the safety in the roads, and higher density in terms of the volume of things connected at the same time. In terms of use cases, you can see here different collision avoidance, queue warning, etc., mainly focused on the safety side of this story. And it's absolutely linked with the V2X, no? So the communications vehicle to infrastructure that means at the end a relevant push for the autonomous evolution in the next years, going to the fourth and fifth level, for the autonomous car. From Telefónica, we are absolutely believers in this new generation, and we think that will mean a huge step forward for the connected car industry. Nowadays, we are working with the 3GPP Association for the standard definition, but we are also working with other initiatives and other associations, like the European Automotive and Telco Association, working with the European Commission for different testbeds. But we are also working with the 5G Automotive Association, where we are working with the different private players, like vendors, OEMs, of course, and other telcos, to promote this standard as something key for the next years. And today, and my colleagues will enter into more detail, we are also presenting an initiative with Ericsson and Idiada to promote the testing for the 5G, especially for the OEMs, to make this possible. Thank you.
So thank you, José Manuel. Our next speaker is Javier Barahona. He's Deputy Head of Global Customer Unit Telefónica. In this role, Barahona is responsible for driving the Telefónica relationship. With more than 30 years experience in the telecommunication industry, He has been with telecom since 1987. The title of his presentation is A Never-Ending Evolution of a Dream. Very inspiring. So, Mr. Barahona, please.
Thank you, Marcos. First of all, I mean, maybe you are thinking that I'm in the wrong presentation, in the wrong booth because of the title, but well, I will try to do something a little bit better because after all the presentation that you have today here, I think that will be quite difficult not to repeat all the time because I think all the principle has been said. Why this title? Because I was working in the telco area and telco domain. When I was asked to do this presentation, I will say, well, why I'm not going to look into the car industry, the history of the car, and then to see what similarities we could have between the car industry and the telecommunication. And then, looking into that, I found this Henry Ford, that for sure everybody knows who was Henry Ford, that he was one of the main drivers in this industry. And then probably one of Henry Ford's obsession was to make cars available for everybody and really affordable for everybody. And then that is what will be about my presentation. But in this case, it's not just the car as such, but the connected car. Why also? Why Ericsson? We are here because this is the automotive industry, and then we are here because of business. Is clear. We have been looking into. I have been looking into as well about some figures. And depends on the sources, it seems that by end of last year, there was around 1.3, 1.4 billion cars in the planet. What is a big growth if we compare with the 700 million that there were available in the 2004. It's a really growth rate. And also, if we look into the prediction, there are different trends because there are some predictions that they said that by the 2030 or so, that could be around 2 billion, so a little bit more than 2 billion cars in the planet. And other that they said that that figure compared with today, that could be flat or lower because of, different reasons. This business model in car, because we had heard about that this car sharing. Some gurus, they said that in the future we will not have a car. We will use a car for when we need it. We will leave it. Somebody will take it, and that is, and then that could produce the reduction on number of cars or just keeping flat. Another trend is just CO2 emission. That also, I think everybody is concerned about the pollution in the cities, and also we will try to find out solutions that to reduce. Cars is one of the producers, but the technology is changing just to avoid that. But in any case, depends if the trend is that we are going to have more or we are going to be flat or a little bit less. We are talking about more than 1 billion cars to be connected. And in the case of the car, what is absolutely clear, no doubt, is those cars that will be connected through a wireless network. And then when Ericsson came into the stage, because I think we are still one of the most relevant players in the wireless industry, and I think is for sure we are going to be in the future. And then we really want to be part of this, as I said before, we really want to be sure that connectivity, in the same way that Henry Ford was trying to make the car affordable and available for everybody, we want to do this affordable and available for all the cars. And this slide, I will not go into much detail, just only some topics, because I think has been already remarked in the previous presentation. Today, car connected is already real. We use for telematics, we use for infotainment, we use for management fleet, even we use for safety. and there is different use cases like, infotainment as such, navigation, opening and closing doors, remote control for heating and cooling. I mean, there are a lot of use cases already, and with the current technologies that we have today, I mean, those services that can be provided, and there, but there is one problem in this, I will say, in this current solution, that there are, let's say, proprietary and vertical solution, okay? And that works from now on. But what is coming, we are going to go to the, tomorrow we will, this kind of services and use cases will change, because we will go to something that we call this intelligent transport system. And then it's not that just is a car is talking with a network. I mean, in this intelligent transportation system, or also called collaborative intelligent transport system, cars will talk with the networks, cars will talk with cars, cars will talk with pedestrians, cars will talk with the infrastructure, and vice versa. And then this is something that is extremely much more complex, and that needs to be really well standardized, because otherwise that will be a mess. Also, those kind of connection, they will put on top of the technology new requirements, because I mean, when we are talking about use cases like autonomous driving, then we will need much lower latencies than the one we have. That is why we will need in the future, for sure, 5G, and who knows, for 6G or whatever. But now, for the time being, we foresee that we will need a technology allowing us much lower latencies. How this should work? You know, I mean, you can see maybe there is a rather complex picture, but it's not. I will really try to make it really simple, because what we have, let's say, we have three layers. That is the connectivity layer, is where the current service provider today, that is the telco operator, they have to communicate with the vehicles, they have to communicate with the infra, they will have as well to communicate with pedestrians. And that is really important, that those interfaces are really well standardized. I mean, now there are tracks in place, 3GPP is working, LTE is working, trying to define those interfaces. That is key, because one reason, if there is not standardized, we will find a lot of problems, because we will not be able to communicate, we will have problems with roaming, and then when car is out of the certain coverage, that will not work as it should, and so on. And the second, that we cannot forget, that also extremely important, is the upper part. That is the application. I think we have also to define a horizontal open platform with APIs, just to be able to create an ecosystem who is deploying application for all the parties. I mean, application that could be for the O&Ms, application for the car owners or the end user, application for the authorities owning the road, the railways, and so on. And then everything has to be really open and standardized. Because also when we were talking about availability and affordability, I mean, if that is standardized, that will mean that there will be a huge competition. And huge competition means huge offer. And huge offer means efficiency. I don't know how I'm doing my time, but just to summarize the three messages that I was saying. I mean, it's important, standardization is key, because we will not get scale, and we will need interoperability, because otherwise, I mean, the service that will not work everywhere. And third, the ecosystem, because the ecosystem, and I said, I mean, we have been having in the history different generation of the wireless communication, and then this ecosystem has to be able to create a proper balance between all the parties in the value chain. You know, I mean, at the end, the O&Ms, authorities, app developers, car owners, service provider, device provider, everybody has to get benefit. Some of them that can be business-wise, that they say, I mean, network infrastructure, device provider, service provider, they will get benefit. But the other parts, that could be the owner or the authorities, they could get another kind of benefit, that cannot be business, but that could be comfort, security, or efficiency. And my last slide just is to explain what we are doing with this alliance between Idiada and Telefónica. I mean, Ericsson, with more than 140 years of experience, we have a lot of knowledge about how to develop, how to innovate, how to make research in functionality when it comes to the mobile network. But the devices, in that case, normally there was laptops, that could be a smartphone, that could be modems or whatever, that was kind of simple to test and to verify what they are doing working properly. But when we are talking about cars, it's not so easy. I mean, it's not something that we can do at home, that we can do in the garage. We have to have a real environment where we could test all the things. And then basically what we have joined together is that Idiada they are putting a circuit where we can really test whatever we are doing. I mean, all the trials, POC, research, innovation, but testing in a real environment. But in a real environment, just simulating normal way of driving, but also extreme condition, what is really important, because safety is key. And to make it really real is Telefónica. Telefónica, what is providing? Telefónica is providing is a real wireless access network, but with real frequencies and with real equipment. It's real. It's exactly the same network that we are using to make phone calls, just to be sure that what we are testing is real. And we as Ericsson, what we are putting is the network behind and our knowledge and competence to make all the text. That is. Thank you.
So thank you, Javier. Our next speaker is Mr. Abel Carbonell. He's head of the electronics department at Idiada. He studied electronics engineering in Barcelona UPC, and he's having more than 20 years experience in automotive engineering, testing, and homologation services. In the recent years, he has been leading development of ADAS and connected and automated vehicle services at Idiada, where he managed a team of more than 100 engineers devoted to design, integration, and validation of electronics automotive systems. The title of his presentation is "Can 5G be the key enabler of automated driving?" So please, Abel, the floor is yours.
Okay. Good afternoon, everybody. So I have the honor of doing the last presentation of the day. This means that it has to be really good because I know you are very tired, as me. Okay. So I hope you enjoy it. Okay. So let's go for it. So we are the guys of the cars, okay? So Idiada is dealing with cars, basically. And this is where we have our partners here, Telefónica and Ericsson, who is helping us in understanding what the connectivity can bring to the cars, okay? So what I will try to do in this presentation is from the part of the OEMs and the vehicle manufacturers and the vehicle engineering like we are, what can 5G bring really to automated driving? Okay, I think we are all very convinced that this is helping, but let's convince ourselves. Okay, so let's have a look at that. So as I said, this morning everybody was talking, during the day everybody was talking, yes, vehicles need to be connected to be automated. So why? Why this is true? Okay, let's see if we can really believe that or not. Okay? So what 5G is supposed to bring to the automotive? Okay, so today we have vehicle to infrastructure services. Some of them, all of them have been already commented during the day. So infotainment services, e-call, all the services that you know very well. Okay, Maybe the most innovative one is the over-the-air software updates that now OEMs are starting doing with vehicles. Okay, but at the end of the day, we don't need 5G for that, right? So this is 3G, 4G. So this is something that is already happening, no new. So 5G is not helping so much in this. This is done, okay? But what about automated driving? Why we think automated driving needs something more that is not there, okay? So let's have a look at what is automated driving today. So basically today what we have is vehicles that are based on sensors. Yeah? So the technologies on automated driving are basically sensors that are trying to understand what is happening around the car and reacting to that. So we have cameras, we have radars, we have lidars. And these sensors, as probably you have tested in your cars, these sensors, they have limited capability. Okay? So there is something to improve there. When it's raining, when it's snowing, when maybe the conditions of lighting are not so good. These radars are suffering. These sensors are suffering. So there is some room to improve here. Okay? There is another thing to be improved. Some of you know that there is some regulations going on what is called vehicle-to-vehicle technologies based on Wi-Fi systems. Okay? Most of us, of the people here, don't like this. I know. We are all coming from the mobile industry, the automotive industry. So these systems, we know that market penetration is very low and it's going to be difficult to be implemented. Okay? So is 5G really the key to improve these things? Can 5G really provide what is missing on the sensors, what is missing on the connectivity between vehicles? So let's try to see if this is possible or not from the point of view of the automotive side. Okay? So I try to show you some examples of functionalities as defined in the automotive sector that are based on vehicle-to-vehicle communications. Okay, so it's not referred to the infrastructure. So these are really interaction between cars. So we are talking about basically safety functions. So the video you are seeing, for example, this is a Cooperative ACC. So this means these trucks are exchanging information on real time. They are having also sensors like radars and cameras, but at the same time they are using a Wi-Fi system to exchange their positioning. So even if it's night, even if it's raining, the truck knows that there is a truck in front of it. Okay? This, for example, this was done in our facilities using Wi-Fi technology, but we know that our colleagues from Ericsson have done exactly the same thing using 5G technology. So it looks like 5G can do these kind of things. Okay? We have other functionalities there, just mentioning very, very easily. Incoming traffic assistant. So what happens when you are going to overtake a car and you cannot see the car that is coming in the opposite direction. Okay? If you can have information from this car coming, you can anticipate. You cannot rely on the sensors in this case. You cannot see this car really. Okay? The same thing for intersection traffic assistant in the cities, for example, or connected horizon. Or, for example, a case that I think it's very easy to explain, emergency braking. This functionality is already there in the market. If you have a standard car, today many cars are having this functionality as a standard device. So you just hit a radar that is detecting a car in front of you and is braking in case you are so close. So let's analyze how this function is working in a traditional way and what should be working using 5G technology. Okay, so in the traditional way, we have a car driving, for example, at 140 kilometers per hour. This is in Germany, for example, not in Spain. Okay, and this car is equipped with an AEB, autonomous emergency braking system based on a radar. Okay, this radar, standard radar, is capable of seeing a car in 150 meters distance. Okay? So this means that everything that is beyond 150 meters is not existing for this car. Okay? So he's reacting to what is happening in front of him. So this means that he has little field time to decide what to do. Okay? For example, you need to know that if the car decides to brake in this situation, once he decides that he has to brake and he starts braking, 20 meters are gone. Okay? So this means of these 150 meters, we have lost 20 meters because there is a reaction, electronic system saying the car, you have to brake. There's a hydraulic system that is pushing a brake and needs some time to put the pressure on the brakes. So this means that 0.5 seconds, this is quite common number, are gone. Okay? Then we have to brake. Physics are there, okay? Are still there, even in the digital era, okay? So we need 85 meters to brake a car from 100 kilometers per hour to 0, okay? So this means that if you put everything together, the system has a margin of 1 second, that at this speed is around 45 meters, is a lot, okay? To decide what to do. If it's raining, or it's snowing, or we have fog, these numbers are much worse, okay? Because the reaction time will be the same, but the car probably will be not at 150 meters, will be maybe at 80 meters. So the possibility of avoiding the collision is going down quite a lot, okay? So our 5G is, with using 5G, can we improve this performance of the systems, okay? Before that, I'll show you this test that we have done in our facilities, okay? In sunny day, weather conditions perfect, the asphalt is completely dry, visibility is perfect, okay? So this is a typical test of AB, okay? Okay, so as you can see, in perfect conditions, the system works, okay? But in not perfect conditions, this is not working. So there is room for improve here, doing more things, okay? And here is where, as a technicians, we say, okay, what can 5G bring to the automotive industry in this sense, okay? So the guys from Ericsson say, don't worry, 5G will have device-to-device possibilities. You can send information to a car, to another car, and you have no delay. So 450 meters of range communication. As you can see, this is much higher than the 150 meters we're just showing. Okay, so in this case, this looks quite interesting for us. Okay, if you talk about the latency, Ericsson 5G technology is saying less than 10 milliseconds I need to send information. Well, this is quite good because compared to my 5.5 seconds that I need to react, this is not affecting me so much. It's generating a very short delay in my reaction time. So this is also quite good. I have a bandwidth of maybe 15 gigabits per second. Well, this is much more than I need to send my GPS position and maybe some other more information I need to send from one car to another. Okay? And finally, what I was saying at the beginning, very important, device-to-device communication. Right? This is generating a lot of possibilities in improving the safety in the cars. Okay, so looks like 5G can bring a lot of interesting things for the automotive industry, not just on the connectivity side of the infrastructure, but also on the safety part of it, and on improving and really providing automated driving functionalities to the cars. Okay, so to conclude my presentation, can 5G really be the key enabler to automated driving, to what we have seen very, very fast? So I would say that on services based on V2I, what we call vehicle to infrastructure, for sure it will bring a lot of improvement and a lot of services that have been explained by our partners. So we are convinced that this is going to happen. On the performance of the 5G, on the expected performance, looks like if this is happening and the technology is really doing what it's supposed to do, we'll be able to really, let's say, improve the current systems that we have for automated driving, to improve the sensors, to improve the reaction times. So any type of driving scenario, in any type of environmental conditions, the cars will be safe. Okay, so this looks quite okay, but of course, there's a lot of things to be done before that, okay? And this is exactly what we are explaining today here, okay? So we have 3 companies from, as we said, from 3 different worlds coming together to see if this is really going to happen in the next future, okay? So What we are putting here, as we have seen before, is that we are creating an environment where we want to generate the conditions to test all these services, to test all these tests in a safe condition. So before we go to the market, before the mass market OEMs and the mass market services companies, wherever they want to put their systems into the street, they need to be ready with the solutions. Okay, so we think that this is the way to go. There is a lot of work to be done, but we think we are on the right path. Thank you for your time and thanks for your attention. Thank you.
So thank you, Abel. I think it were a very interesting presentation. I still see many people here, so I hope we pitch the audience. So I would like to hear some questions. So does anybody want to ask something to our panelists? Please.
Hello, good afternoon. Thank you for your talk. Very interesting indeed. So I'm a researcher indeed in 5G for the connected car, and I'm always asking myself, why do we need such a low latency? And the last presentation was very interesting because you put the numbers. And if the reaction time is of the car, I understand, is about half a second, why do we need 5 milliseconds in the connectivity thing? From your numbers, I think that the most important thing is the range. So if you gain in range, that's it. So what is your point of view on that?
Hola? Hi. Yeah, probably I missed something in my explanation. Yeah, there is a big... these conditions I was showing were ideal conditions. So you have one car and one car on the road. In these conditions, of course, you don't need 10 milliseconds. But what happens when you are surrounded by thousands of cars, well, not hundreds, but hundreds of cars or dozens of cars. This means that you have to manage a lot of communication with a lot of cars that are driving around you. So if the time that you need to talk with each one of them is high, probably you are not hitting the right car on the right moment. Okay? So as fast as you are exchanging information with the others, much things you can hear and you can react. So I think this is very much linked to how you manage the how it's called, I don't remember the name, but the congestion of the information between the different cars. Okay, so this is critical in this case. Okay, this is critical.
But if may I add something, I would say that beyond the safety, the low latency, I think that is really interesting also that we are moving the processing capacity or part of the processing capacity from the car to the network. And at the end, from the commercial perspective, it's really interesting because we are reducing the cost or the expected cost of these vehicles for the end users. So that's something also worth or interesting from the B2X communications.
Okay, very interesting. Can I do another question?
Please,
Indeed,
feel free.
Indeed, there are two questions now because you have added a new domain. But first, coming to the latency, I see your point that you need to manage a lot of devices at the same time. I still don't see clear why do we need such a low latency. You know, do we really need milliseconds of response? So the question is, have you tried with 4G?
No, the thing is that what we need is to have device-to-device communication with a low latency. How much low latency? We need to probably more test. Question here is that if you are using a network like 4G that is not doing device-to-device communication and you are depending on some information going to somewhere and going back to the car that is in front of me, it's not a question of delays. Maybe this information is not arriving really on time because I'm depending on the status of the network and maybe this network is really not available and the delay is infinite because the information is not arriving never.
Yeah, but see that this goes against the comment from the other speaker. Sorry,
but these are different things.
José
On
Manuel.
safety, but I think this was more on services. I was talking really more about safety. Okay, you are talking about safety. Okay, a different thing. That's right.
If you allow to add something, I mean, if we talk services like remote driving, and when you are measuring latencies, you have to measure the latencies in the different segment of the network, and then because you have the car, and then you have the radio network, you have the transport network, you have the core network, and then there are different paths within from that service, for instance, from remote services, and then you have to reduce the latency as much as you can in all the parts, and then because normally if you don't reduce, you don't get those latencies in the radio part, you will not manage probably to do those services like a remote driving. It's just a request from the services.
Yeah, no, I see the point, but the question is, have you tried? Now we are going to start a project on 5G with Ericsson indeed, and I am always saying the same thing, so we have to go beyond the 5 millisecond. But I wonder if you have tried, because you have this nice demo at Idiada, I wonder whether you have tried already with 4G. Because it's true, you need the end-to-end low latency. I see the point. But what I still am a bit skeptic about, do we really need this 5 millisecond threshold that we are kind of defining? Have you tried with 4G and 3G?
No, we have not. We need to try, but I think that, from our side, we have not specified which is the maximum delay we need from the network. What we need to know is that this delay is under control. And with 4G, you are depending on a network that is not under your control. So no car manufacturer is going to rely for safety in a network that is not under his control, because you cannot ensure that the response of the network will be always the same. Yeah. So if you're using device-to-device technology, and this is just depending on you talking with a car in front, you have things under control. And this is the big difference, I would say. Okay.
And if you allow me to add something else, 5G is a new technology that is not only for the automotive sector. Is for other sectors that they will require that technology. And also, when you are developing a new technology, I think we have to try to put requirements beyond what the current needs, because for sure, in the coming years, we will have new services or new demands that we cannot foresee today. But I think if we are doing a big investment in developing something, I think it's really important just to put real, tough requirements, just to go beyond. We are not going to develop something to go with the current needs. I think we have to go beyond that.
Yeah, no, I fully agree. I fully agree with that, and also with the concept of determinism. But we need deterministic networks, probably more than very low latency networks. I agree that if we have to reduce the latency, it's good to go as far as we can. But probably 5G is more about getting a deterministic performance. This is what I think, and I tend to always listen to the same high reliable, low latency, but maybe deterministic should be also a key word that we could add to the selling story of 5G. Well, okay. Thank you.
Thank you very much for your questions. So, if I may add, so in the Mobile World Congress, actually, we had a demo where we made this remote driving reality. So Telefónica, Idiada, and Ericsson made this through a 5G network, 70 kilometers away, make a reality. And this is reality because of 5G networks. So this is a good example, and then we might end up discussing about other use cases, cooperative ACC, platooning, that probably 5G networks are require this kind of latency. But okay, so let's be fair, let the others ask some questions. So please, any other questions from the audience? Okay, then I will make a question, and this is highly related to what José Manuel Caramés already mentioned regarding how 5G is moving this computational towards the infrastructure. So I would like to ask you, so how 5G networks are going to impact connected automated vehicles, so the deployment of these devices?
Well, I think that at the end is all related in the different presentations and questions we have had. We think that, as you have seen during my presentation, we think that 5G at the end is being or joining both sides of the story, or both parts of the story. So one will not enable but improve all the infotainment and services on board for the passengers and the drivers. And the other side is the more simpler one in terms of the lower latency and the lower data traffic, etc., that will enable the answer and the questions that we have just had about the vehicle-to-vehicle communication that will impact for sure in the safety. And as I said before, I think one of the other key points that will impact in the industry is that if we are moving part of the processing from the local, from the vehicle to the network, this is also something that will be also key for the development of the industry.
Okay, thank you. So I have another question, and excuse me. So I have another question, and this is related to the deployment of this 5G network. So Manuel showed how the technology is evolving. He provides some hints about where 5G networks will be available, and this will be impacting connected automated vehicles. So I would like to ask Mr. Carbonell if connected automated vehicles will follow the piece for the deployment of these systems. So when connected automated vehicles will be deployed in public roads?
Well, this is a tough question, my friend. Well, I would say that we all can see that the vehicles manufacturers are moving very fast in this, and we can see some of them saying that in the next 3 to 5, 6 years we'll see some of these cars in the road. But these cars basically are cars that are reacting to what others do. So these are cars that are intelligent in a way that they see things around and they react according to that. Okay, but I think we all agree that without connectivity, this is not really an automated driving car. Okay, so automated driving cars, including connectivity, vehicle-to-vehicle connectivity, this is what I really believe this is a real automated car. And I think that a good example of this video I show you there, that probably is the best or the first commercial example of automated driving using connectivity that will be there out in the roads in the near future. And I don't think it's going to happen very late. Probably in 4 years, 3-4 years, we'll see in the roads trucks like the ones you have seen here that are automatically driven one after the other using vehicle-to-vehicle communications, using connectivity systems, and that is going to happen soon than probably other systems.
Thank you. So do we have any other questions from the audience? So I still have one more question, and this is to Javier. So this is related to you. You provide some insight about the importance of interoperability, standardization, so that they will be key enablers of connected automated vehicles. So could you elaborate more about the importance of these standards and the interoperability in the domain?
Yeah, sure. As I was starting in my introduction, that when Henry Ford was trying to deploy the car industry, he was thinking about to make it affordable and available. I mean, standardization and interoperability is key because it's the only way really to create a scale. And without a scale, we will not manage to make to have a massive deployment. Because it's key. I mean, if it's not this affordable, I mean, we could have wonderful things, but that will be only used for the small portion of the world or for a small portion of the population. But I think we have a good track with what has happened, that it has not precedent in the history with the mobile telephony or the mobile communication. You know, I mean, we were doing, 30 years ago, 40 years ago, we were doing prediction about that. Well, I don't know, I think will be 10,000, maybe 100,000, maybe in a million then. And now, we are now in 8 billion of connections, you know, and then that is why. What is the big difference compared with other things? That was standardization. That was interoperability. And when you do so, you make it really affordable for everybody, and that is the key. And this is in the automotive industry. I mean, we are talking about the big volume. That is, we are talking about between 1 or 2 billion cars to be connected, and that is really important, because at the end of the day, I mean, we have been talking about technology, but the technology is just an enabler, because what we have to be able to provide is value. I mean, we have to provide value to the end user. That can be different in the case of the automotive industry. What we have explained before, there are different end users that you have to provide value. But at the same time, to provide value, all the parts in the value chain has to make profit, because otherwise that will break. And if they break, everything will go out, you know. And then that is, for us, interoperability and standardization is key.
Absolutely. Thank you. Thank you. So, do we have any other questions? So, otherwise, I would like to thank all the speakers, because I think was very interesting. So, how they explain how 5G is evolving, is transforming society, new opportunities that are arising. Our colleague from Ericsson, he emphasized on a proper ecosystem. We need standardization, we need this interoperability between devices, and then Mr. Carbonell emphasized in the idea of that there will be application use cases in automotive that they are demanding these 5G networks, and connected automated vehicles probably will be a reality with a key enabler as 5G. So I thank you very much for these interesting presentations. So please, a warm applause for them.